On 9 through 11, we're referring to this rectangular playground, and she's told that one of the sides has to be 100 yards, or the width has to be at least 100 yards, and the total fencing has to be 350. Well, since we're going to graph this, let's define our length to be x, our width is y. So my first solution, or my first inequality I should say, is y has to be less than or equal to 100. And then we're doing perimeter, so I'll say 2 times the length plus 2 times the width, and she wants that to be no more than 350, so less than or equal to 350. Now this is really all you need for paper, but if you do this on Desmos, you better define that x has to be greater than or equal to 0, because you can't have negative numbers, which, if I skip ahead, we can answer question number 11. We can say the length can't be negative. Now I've graphed this system already on Desmos so we can see it and save some time. So notice y is less than 100, so y is the purple region. 2x plus 2y is less than or equal to 350. And so that is my dash line there, isn't it? And it's less than, so I'm underneath that. So I'm going to have, oh, I didn't graph, I just noticed, I didn't graph x has to be greater than or equal to 0. That makes it easy to see. So then everything in that triangle is going to be in my shaded region. There's going to be a solution. So the first question, we're going to go back and forth here between these two, says, hey, can you have a fence of 70 and 100? And notice that there's more than one correct answer. So if I graph 70 and 100, notice that is on the border. So that would be a solution. How about 75 and 105? So what I'll do is I'll do 75 and 105. And notice that one's on the outside, so that's not a solution. How about 80 and 100? Okay. So if we do 80 and 100, once again, outside my solution triangle, so that's not the correct answer. Okay. And then 85 and 85, let's try that one. And notice that's outside my solution region. And then in the last three, I kind of threw in I get rid of the length and width and just with ordered pair, 25 and 150. So let's do 25 and 150. And that is on my line inside the triangle, so that would be a solution. So 25 and 150 is a solution. How about 50 and 125? $50 and 125 is also on the edge of the triangle, and since it's less than or equal to, that would be a solution. And finally, let's do 75 and 100. And 75, 100 is just on the corner, and since they're solid lines, that's a solution also. Okay, finally, on this page, let's take a look at number 12. Systems of inequalities with parallel boundaries have no solution. That is true sometimes. It's not true all the time. And I put in a pen instead of my marker, so I'm going to redo that part. Okay? Because when we take a look at this, let's talk about what it is, okay? So if I have a system of equations, one's greater than, one's less than, and like in this case, the top one would be greater than, the bottom one would be less than, that would be no solution. However, if I have that same system of equations, and let's say they're both greater than, well, if they're both greater than, my system would look like this. So really, my solution where they're both true would be that part right there. Let me change that to a pen so you can see. So this would be my solution if they're both greater than. Okay? And then I could have just the opposite. If the top one is less than and the bottom one is greater than, then I might have a solution where the solution's in between the lines. So it could be, that would be true sometimes, but it's not all the time, so that's what we're going to say sometimes for a solution.